Let's talk about the NumPy library a little more. I just wanted to play with it, show you more examples because this NumPy array is one of those libraries that is widely used for AI, um, data mining, and machine learning and data science and stuff. It's a list on basically asteroids. Like it gives you, it allows you to work with. Um, Arrays of numbers a lot faster. It gives you so many methods to work with the number and play with the number. It allows you vectorization and vectorized calculation and all those um, fancy things that if you want to do with the normal list, you have to write a lot of code and deal with a lot of details. So I have this file. Let me just go through this so you can see how everything works. Let me run this one more time so you can see how fast everything gets run. All right, let me find the beginning. There we go. Okay, so I'm using NP as an alias for the NumPy. So I give it like instead of using a normal array, I just give my normal array, call this array function, and now I have a NumPy object. So I print it. There we go. I have a list of numbers. It shows the elements the same way that it shows a list because they're kind of the same. It is holding all the elements as a list behind the scene. Um, and I'm using the random and random integer method to generate 1 million random numbers from 0 to 1000. And this is going to be another NumPy object. And you can see that we can use a slicing to just grab the first 10 elements. So I just grab the first random um, 10 random integers that I generated so you can see what they are. Um, and like I said, it's perfect for vectorized operations. So I don't have to loop through everything, all the elements, and multiply them by something. I just say, okay, all these NumPy, I just use my NumPy object and I just multiply it by something, and it's just going to apply that to all the elements. So I just did that and I'm just printing it. Look at that. So it multiplied all the elements by 1.1. Um, and what I'm doing, I'm just creating a new NumPy array and look at that. I just subtract all the elements by 32 and then multiply by um, 5 times 9. So I'm just converting all the numbers at the same time to Celsius with no looping at all, which is one of the beauty of using the NumPy array. And it gives you a bunch of super useful methods. So you don't need to loop through all the elements and grab all of them and add them all up to get the sum. It has a lot of methods for aggregations. You can just call the sum method. It goes through everything and calculates the sum or give you the average or finds the maximum or minimum. Same thing I did with the other NumPy array object that I have. You can just call the min and max. There are so many of these useful methods. Um, there we go. It shows the average, the minimum, the maximum, the minimum and maximum sensor reading value that I have generated randomly. Um, and look at that. Like we can actually kind of filter out elements without looping, without condition, nothing. I just throw my condition between brackets and boom, it's just going to give me only elements that are fulfilling this condition. So I'm just saying I only want the sales that are greater than 1600. There we go. This is the list. So it's returning that list for me. Um, or I'm gonna say, you know what? I just want to sensor readings greater than 900. Boom, like that. You can get all just those. Um, and and then I'm printing the size of it. Okay, I was looking for all the elements. Yeah, I'm calling this size property on that, which is nice, and it only tells me how many elements now we have inside this NumPy array. So You want to get the size of your NumPy array, how many elements you have, you just call this size property. That's it, super easy. Slicing, I just showed you. Um, we can use a slicing on the NumPy to just grab a specific part of the list. But this reshaping thing is just another level. Like I want to convert my list, which is one dimensional, into a table, like two-dimensional table. You just call the reshape method and you just give it how many rows and columns, and boom, it's just gonna convert your one-dimensional into two-dimensional array. And it uses the elements with the same order. So boom, now we have 4 rows and 3 columns on each row. This is something that if you wanna do with the normal array, you have to write like a nested loops and stuff like that. You want to combine two NumPy arrays. You can. There are so many methods for it. So column stack is one of them. It's very useful. You do that with when you're studying your data for any AI or machine learning stuff. Column stack basically it just gives you two columns. Each column represents one of the NumPy array elements, and it just puts them together side by side. Look at that. So it just gives you two columns. The first column are representing all the elements from the first NumPy array. The second one represents all the elements from the second NumPy array. So we just can reshape our list um, and combine two NumPy arrays like just easy by just calling a method. It's just so convenient using this NumPy array, which is why it's very popular. Um, and now look at that. Like I have like a two-dimensional array. I want to say, okay, I want to sum up all the elements, but I want all the results to be converted into one-dimensional again. That's all you need to write. And boom, look at that. It um, gets the sum of all rows and then it returns all of them as one dimensional. So look at that. So we can actually check. So adding this and this should be exactly 4,250. So basically is adding up all the sum of all the rows and it just give us one dimensional array as a result, which is very convenient. Another thing, like you can sort all the elements just that easy. You just call the sort from NumPy library and it just sorts everything. And I'm just saying, okay, just show me the last 10 elements, which are basically all the same. Um, like you want to find unique elements, you can just call the unique method and you just set this return content to true. Um, and that's it. Look at that. It just gives you only the unique numbers. And then you want to say, you know what? I want to also know how many of those I have. So basically, when you call the unique one, it basically returns two values, the list and the number of occurrences of those elements. So A is going to be repeated 3 times. B was appeared in this list 3 times, and we only had one C. Very convenient. Um, Another example. Okay, this is actually good. This is actually one of those things that we use for working with the data and preparing the data um, in machine learning and AI. So let's say you want to generate a list of normalized numbers. You can just do that. So we are randomly generating numbers. This would be the mean of normal distribution. So that means all the numbers that we want to generate, we want them to be close to 50. This is the standard deviation. So that means we want to go 10 up, bigger and higher and lower than this number. So all the numbers going to be between 40 and 60. And then we want to generate 10 of them. So that's it, just that easy. Look at this list that it was generated by this line. So all of them are around 50 with the standard deviation of 10, which means like 10 higher and 10 lower starting. So all the numbers are generated between 40 and 60. So there are so many. These are just some examples, but I just wanted to show you how great this NumPy array library is. All these things that I just showed you, they have real application when we get to a point that we want to prepare our data and understand our data for implementing any AI or machine learning algorithm on the data.